Okay, so my name is Ammar Mujahid, and this talk is all about the representation theory of groups. Two things majorly we will study in this talk. The first one is a trace of a matrix, and the second one is a character of a representation of group. What is the trace of a matrix? Let's suppose we have a matrix A, which is an n cross n matrix. It means it has same entries. It has same rows and columns. Then trace of A is equal to summation I is equal to 1 to n A I A, which means the sum of all the diagonal entries of the given matrix A. The next thing is the few properties of the trace of a matrix. To study about these properties, we define here the two matrices. The first one is A and second one is B. Both are n cross n matrices. Then the first property is the trace of A plus B is equal to trace of A plus trace of B. And the second property is trace of AB is equal to trace of BA. And moreover, if T is an invertible n cross n matrix, then we have another property. Trace of T inverse A is equal to trace of A. We can prove it easily by using this property. Trace of T inverse A is equal to trace of T inverse into AT. We can interchange both of them. So finally, it's T and T inverse. After multiplying it becomes the identity matrix. So it makes no effect. Then finally we get trace of A, which is equal to trace of T inverse A. The next thing to study is the characters. Suppose that we have a CG module with the sum basis beta, and we call this CG module B. Then the character of B is the function, we call it sigma, and it's the function from G to C. The G is a group and the C is the set of complex number, which is defined by the sigma of G is equal to the trace of G beta, where G belongs to G. Remark, the character of CG module does not depend on the basis of beta. Since if beta and beta dash are the basis of V, then we can check it. G of beta dash is a matrix which is equal to T inverse J beta T for some invertible matrix T. And so by previous property of trace of a matrix, we also can check it. Trace of G beta dash is equal to trace of G beta, where G belongs to G. The next thing is a character of a representation. Character of a representation of a group. This is a representation of a group. For this group, it's a finite group, and the mapping from this group to GL and C is an invertible n cross n matrices. Which is the entries of these matrices depends upon the complex number. Right. Then we can define the character of this representation is as sigma of D is equal to trace of rho of D. Remember, rho of D is actually belongs to GL and C, which is a set of invertible matrices. So sigma is the character of G if sigma is the character of some CG module. The next we can also talk about the irreducible and reducible characters, but this depends upon actually the corresponding CG module. If this CG module is reducible, then we can say that the character of its representation is reducible. On the other side, if this CG module is irreducible, then we can say that the character of representation of a group is irreducible.